Hi guys, I'm going to try this again. Apparently the first video that I recorded came out all wrong, like a chipmunk. So for this video, you're going to need your handout, which I gave you guys today. It's 4-7, Study Guide and Intervention, Transformations of Quadratic Graphs. You should also have a separate sheet of paper because we're going to need to write some things down that we don't have enough space for on here. And then it would probably be helpful if you had a colored a highlighter or a colored pencil or a different colored pen or something to help you with the lesson. Okay, so we're going to go ahead and get started. The first thing I'd like you guys to do is I just want to remind you, of course, to put your name, date, and class period. But we're going to highlight some of the important information from this handout. As we learned today and Friday, we've been learning all about transforming quadratic graphs. Okay, so parabolas, which is a quadratic function, can be transformed by changing the values of these constants a, h, and k, as long as they're in the vertex form of a quadratic function. So all of these are important words to highlight, Transformed. How are they transformed? By changing the constants a, h, and k. What form does it have to be? In vertex form. So far we have a couple of vocabulary words here. A constant is important for you to know. A constant is a number. And a variable would be a letter. Okay, so a constant is a number that is just changing. It can be any number we want depending on what we want it to do. Okay, so a variable is a letter. Okay, so we learned today that the value of a determines whether the graph opens upward or downward. So it opens upward if a is greater than 0 or positive, and it opens downward if a is less than 0. So if a is greater than 0, then that means that a is positive, which means people who are positive always have a nice smile on their face. And people who are negative, or when a is less than 0, then you have grumpy people, people who are always in a bad mood and always find something to complain about, okay? The absolute value of a causes the dilation. So we called it today either stretch or compression. So if a is greater than 1, then it's stretched vertically. So it gets really skinny. Or if it's, and this says less than 1, it should really be if a is between 0 and 1. If a is a fraction, then you're going to compress vertically. Okay, so important things that I would highlight here is if a is greater than 1, then it's stretch. And if a is between 0 and 1 or a fraction, then you're going to compress it vertically. So you're either going to have a really wide graph or a really long, skinny, narrow graph. The value of h is the one that most students struggle with because it's the opposite of what you see. Positive values of h slide the graph to the right. If h is negative, then it slides the graph to the left. However, I told you guys yesterday, or today, I'm sorry, that if you have a function, let's say 2x minus 2 squared, the h in this case is a positive 2. But what you see is x minus 2. So you know that you're going to shift to the right. Shift right 2 units. If h was negative 2, then you would see y equals a 2x minus a negative 2 squared. A negative and a negative turns into a positive. So you would really have x plus 2 squared. So in this case, you see a positive 2, so you think to go to the right, but you're actually going to shift to the left because originally h is negative. Okay, I asked you guys to write down some notes earlier today. You had to write down a sentence and summarize how you're going to remember which direction to go. First, second, and third period, we're probably going to have to do that tomorrow. Okay, the value of k. So k is at the very end of your function, and k is going to move it vertically. So if k is positive, then it slides the graph up. If k is negative, then it slides the graph down. Okay, let's move on to our example. The example, I am going to ask you guys to write it on a separate sheet of paper because we're not going to have enough space. There's a couple of important things that we need to know here, and this graph is really small and kind of crappy, so I don't really like it. But anyways, let's look at, I'm going to get a separate sheet of paper, and you know that we always start with the parent function, right? Without your parents, there would be no u. So it's going to be y equals to x squared. So on the separate sheet of paper, if y equals to x squared, that's my parent function. And if I'm going to come up with the table of values, we know that the graph of the parent function always starts at 0, 0. And the reason it starts at 0, 0 is if I substitute a 0 here, 0 squared has an output of 0. I'm going to go 2 units to the right and 2 units to the left. So if I pick x is equal to 1, I'm really going to substitute 1 wherever I see an x. So what is 1 squared? 1 times 1 gives you 1. Okay, so I would plot my points. 0, 0, 1, 1, and then I'm going to go to 2. What's 2 squared? 2 times 2 is 4. So then you plot that point. Okay, and remember that the axis of symmetry in this case happens right on the y-axis. So the graph is symmetrical on the right as it is on the left. And you're going to see that as we go through the math. What is negative 1 squared? A negative 1 squared means negative 1 times negative 1, which just gives you a positive 1. Negative 2 squared is negative 2 times negative 2, which becomes a positive 4. So the values end up being the same to the right and to the left of the vertex. The vertex should always be placed in the middle. Okay, so when I plot my points, I have negative 1, 1, and negative 2, positive 4. This is your parent function for the quadratic function, the quadratic functions, okay? I have a child, according to the example, that has plus 7 and then plus 3. So in this case, A is equal to 1, positive 1. So we know it's going to be facing up or opening upwards. H is equal to a negative 7. It's the opposite of whatever's written there. And K is equal to a positive 3. So we're going to change the X values by shifting it to the left 7 units, and then the K units by shifting it up 3 units. I'm sorry, the Y values by shifting it 3 units up. So if I take my original parent values, negative 2, negative 1, 0, 1, and 2, and I'm going to add a negative 7. So negative 2 minus 7, negative 1 minus 7, 0 minus 7, 1 minus 7, and 2 minus 7. The reason I'm doing that is because I'm going to take this original graph and I'm going to shift it 7 units over to the left. So I'm going to end up with something like this. Okay, so what is negative 2 minus 7? It gives you negative 9, negative 8, negative 7, negative 6, and negative 5. So now that we have these values, we have our new X values. So that's just saying that I shifted my graph 7 units to the left. And the last thing I need to do is add 3. Add 3 to all of my K values, all of my Y values. So if I add 3 to my original y values, so my original y values were 4, 1, 0, 1, and 4 from my parent function, I'm actually going to add 3 to each y term, and you end up getting 4 plus 3, 5, 6, 7, 3 plus 1 is 4, 0 plus 3 is 3, 3 plus 1 is 4, and 4 plus 3 is 7. So the table of values for your child are actually -9, 7, -8, 4, -7, 3, -6, 4, and -5, 7. So if you look at your graph, the one that's graphed over here on your sheet of paper, that's exactly where those points are. It's shifted to -9 over here, and like up to 7. Let me see, -7, -7, +3, and then -6, +4. No, sorry, it's like too small. That's why I didn't like it. Okay, but you get the idea. Okay, so let's look at the next example, which is exercise number 2.